Hello, my name is Corey, and I'm going to be doing a third part to the FTC Programming Basics video series. So what's included in the video? We're going to show you how to control the robot using your gamepad controllers, and show you how to create a simple autonomous routine. So there is code provided by us in the first SDKs that allows us to use the gamepads to control the robot and allows us to create autonomous routines pretty easily. So if you haven't already watched the two previous videos, I would recommend that you watch them now, because we will be referencing some of the things we said in the previous video. So first, I thought we'd make a simple driving teleop. So this will make us be able to drive the robot around using the gamepads. Some of the things involved in doing this, we will have to name our op mode, import and extend the op mode class. We talked about importing in the previous video. Set up our methods, the init, start, loop, and stop. Declare our hardware, just a couple of wheels. That's really it. And then instantiate our hardware using the hardware map, and use the gamepads to actually drive the robot. And of course, we need to register the op mode. Okay, so here we are in Android Studio, and we're going to go to the directory on the left where you can see what file folder you're in. So we're going to go FTC Robot Controller, Java, com.qualcomm.ftc Robot Controller, and then op modes. And again, this is where all of your op modes should be stored. And we're going to right-click op modes, and we're going to say new Java class, and let's just name it gamepad drive teleop. Hit OK, and it generates the template. So here's our public class, gamepad drive teleop. Make sure it matches over here, which it does. And then we're going to extend op mode like we usually do. And then it gives us an error because it must be imported. And again, from the last video, it's just Alt-Enter, and it generates this. Remember that importing is including something that's not normally included in the default Java set of tools. Now it's getting mad because op mode, when we extend it, it must have two default methods that are made to be overridden. So we'll do Alt-Enter, and then we'll say implement methods. It'll come up with this screen. Just hit OK, and then it'll auto-generate our two methods, init and loop. Remember, init will happen right when you hit the init button once, and then loop will happen from the time you hit the play button to the time you hit the stop button, over and over again, many times a second. So now we'll declare some hardware. We'll have a motor, left wheel, and a motor, right wheel. So we have our two wheels. We must import the DC motor class. So we'll do Alt-Enter, and it generated the DC motor import. Now we will instantiate our hardware. So we'll say left wheel equals, go out to the hardware map, DC motor, and get whatever we put in the configuration file, which we're going to say it's left wheel. And then right wheel is the hardware map, DC motor, get right wheel. So now we've instantiated our left and right wheels. As you can see here, we use this hardware map a lot. Pretty much anytime we make a new op mode, we need to use the hardware map to instantiate our motors and servos and any hardware. So make sure to know what your configuration file names are, because you'll be using them a lot. and if they don't match, then your op mode will not work, and it will give you errors. So make sure that you know these names, because it becomes very useful. And then, as we talked about in the last video, we have to reverse one of the wheels. We'll reverse the right wheel. So dot set direction to DC motor dot direction dot reverse. So now we set the direction of the right wheel to reverse. So just to clarify, we're going into the right wheel, which is a DC motor, and we're saying dot, which is calling a method, dot set direction, so it goes out to the set direction method, which sets the direction, and then we're setting the direction to reverse. So we're going to now set the powers of the left wheel and the right wheel. So we'll say left wheel dot set power, and then for now let's just set it to 0.5, and then we'll say right wheel dot set power 0.5. So now this op mode will run, and it will just make the robot go forward forever, from the time you hit start to the time you hit stop. But we don't want that. We want it to be with feedback from the gamepad to alter this number. Let's make a new variable to hold the power, so that we can then alter that variable and change the power however much we want. So we'll make a new double, and we'll name it left wheel power, and then we'll do a double right wheel power. So now we have decimal point numbers, 2 decimal point number variables to hold the values of the left and right power. So we'll come down here to our loop method, and we're going to actually set these values now. So when you type in gamepad, you can see that it comes up with actually 2 gamepads. So gamepad 1 will be the gamepad that when you press start A, when you initialize the gamepad using start A, then this will actually be gamepad 1, and when you do start B to initialize it, when you actually press the buttons on the controller start B, then that will be gamepad 2. So we'll use gamepad 1 for all of our for anything we're going to do. So we're going to go inside gamepad 1 and look for the left stick Y. So this is looking into the gamepad 1, and it's looking at the left stick Y. This can be a value from -1 to 1, -1 being pushed all the way forward, 0 being not pressed at all, it's just sitting there in the middle, and 1 being pulled all the way down. So now that we have the left stick Y value, we can apply it to our left wheel power. So we're going to do left wheel power equals gamepad 1.left stick Y. So now we have our left wheel power anywhere from -1 to 1, which is what we want, because we can set a motor power anywhere from -1 to 1, -1 being going backwards, and 1 being going forwards, and 0 being off. So now we'll replace this number with left wheel power. So now if the left joystick is sitting in the middle, it gives a value of 0. So when we set the powers, the motor will be off. And then since loop happens many times a second, it will come through again, and it'll look at the value of the left stick Y again, and it'll see if it's changed or if it's the same, and then it'll reset the variable. So the next time it comes through, let's say it's 1, it's pushed all the way forward. So when we set the power to 1, then the motor will be going forward, and then same if it was backwards at -1, the motor would be going backwards. So now we have the left wheel working so that if we push the forward on the left joystick, it'll go forward. If we push backward, it'll go backward. And if it's in the center, it's off. Now all we had to do is the same thing for the right wheel, but with gamepad 1 dot right stick Y. So now we have the left stick controlling the left wheel and the right stick controlling the right wheel. This is what most people call tank drive. This is where one stick controls one wheel and the other controls the other wheel. I'm fairly confident that this is what most teams use to control their robot. So now we have our fully functional gamepad drive teleop, but we need to register it real quick. Just remember it's manager.register. The name of the op mode you want to show up on the phone, which is gamepad drive teleop. And then we'll say the name of the class, which is gamepad drive teleop.class. So now you'll actually be able to run it from the phone and use it on your choice of robot. So I rewatched the video and I noticed that I made an error earlier regarding the joysticks. So when you push forward on the joysticks, I don't know why, but they've programmed it so that when you push forward on the joysticks, it returns a negative value, and when you push downwards on the joysticks, it gives you a positive value. So if you push all the way up, it gives you -1, and if you push all the way down, it gives you +1. So it doesn't really make sense that if we're setting the power to the joystick, that if we push forward, it would give us a value of -1, and then we're setting the value to -1 if it's pushed forward. So currently, if we push forward, the robot will go backwards because it's giving the motors a power of -1. So there's 2 ways we could fix this. One of them is, instead of when we assign the value, we could just make this negative. That would make it so that if we're getting a reading of -1, it would change it to +1. So a negative value on the joystick would be stored as a positive value for the power, which is what we're then giving to the motors. And then same thing, instead of doing it here, we could just do it here. That would give the same result, because this is being stored as a negative value, but then we're changing it to a positive value. And then it looks kind of odd if you set the power to a negative, the opposite of the power. It just doesn't logically make sense, because you were expecting this to return a 1, and then when you set the power to -1 to make it go forwards, it just doesn't make sense. So instead of doing that, you can just, here you could change it to left wheel. So now the left wheel is being set to reverse. So remember when we talked about when you built your robot, the motors are facing in opposite directions. So when you give them the same value, they'll be doing the opposite of each other. So one will be going forwards and one will be going backwards. So to fix this, we made it so that we corrected the right motor so that now they're both going in the correct direction. But this would make it so that the joystick would make the motors, when we're trying to make them go forwards, they'll go backwards. So instead of reversing the right motor, we'll reverse the left motor. And we'll leave the right motor the same, which is basically the wrong direction. So we'll tell them both to go in the wrong direction, which will then make it so that the joysticks will make the robot go forward when we want it to, and make it go backwards when we want it to. So if we reverse essentially the wrong motor, the motor code will handle all the changing it from negative to positive and positive to negative and all of that, so that we never actually see it in our code. It still is a -1 for forward and a 1 backwards, but since the motors are reversed, it's basically like the negative value of whatever's given. So now that we've made a op mode that will drive the robot, let's make a specialized op mode that will actually do something specific to a certain robot. So our goal will be to create an op mode that's specialized for a robot with a servo claw. So let's say that we had a robot with 2 wheels that can drive around like normal, like our other robot that could only drive around. But this one has a claw on the front made out of 2 servos, one servo controlling the left jaw of the claw and one servo controlling the right jaw of the claw. So we'll actually make a op mode that will control the claw along with the drive. Okay, so I'm back in Android Studio, and to start, let's just open up the op mode we just made. So that's the gamepad drive teleop. So here's our op mode that will just drive using the joysticks, and we'll drive the robot with the left wheel and right wheel. So now we're actually going to make it specialized. We're going to alter this op mode to make it specialized with a claw. So for starters, let's rename the gamepad drive teleop so that we'll know that this is an op mode specialized for a robot with a servo claw. So right-click the op mode, and then come down here to refactor, and then we're going to say rename. So refactoring is saying just something that will change something not only within this file, but pretty much everywhere that uses it. So if something else calls on this class, it won't mess up if we've renamed it, because it will rename it there as well. So we'll rename it, and instead of gamepad drive teleop, we'll name it servo claw teleop. So we refactor it, and see here it resets it to servo claw teleop. You can also see that over here it renamed it as well, and they do indeed match. Just to build on the point that it changes it everywhere that calls it, we'll go to the FTC op mode register and see here that this was the gamepad drive teleop. Now it changed it to the servo claw teleop because it knew that this was changed because we refactored it. But let's change this real quick since we're here. We'll change it to servo claw teleop. So go back to your class, and then now we're going to actually get into how to make it so that we can actually use the claw. So we're going to need 2 servos, and one's going to be called left claw, and one's going to be called right claw. We need to import servo because it's not included in the default kit of tools. And then we need to instantiate them real quick. So we'll say left claw equals hardware map dot, and then here we usually do DC motor, but since it's not a DC motor and it's a servo, we need to put servo dot get, and then let's say we called it left claw. And then we'll do the same thing for the right claw, hardware map dot servo dot get right claw. So now we've declared and instantiated the left and right claws. So now we'll make it. We'll make the claw open and close. So we'll make it still be able to drive, but we'll make it have the added bonus of being able to open and close the claw. So let's say we were going to make it so that when we hit the X button on the gamepad controller, it would open the claw, and then when we released it, it would release the claw. So to do this, it's fairly simple. The gamepad class, we can just go to it and get X. So we just do gamepad1.x. And then that'll return a true or false, a boolean. So we'll make an if-else statement. So we'll say if gamepad1.x So this is saying that if the X button is pressed on gamepad 1, then we'll do this. But else, if the X button is not being pressed, we're going to do this instead. So if statements are really good when we're using programming. They're used like everywhere. So in the if statement, we'll put if the X button is pressed, then we'll do left claw dot set position. Now this is different from a motor, because a motor you're just setting the power. You can't actually see what position it's at. But servos, you can tell what position it's in from 180 degree rotation. So this is a value anywhere from 0 to 1. So we want it to be open, so we'll say set position to 1. Let's say that 1 was open and 0 was closed. And then we'll do the same thing for right claw. 1. And then, so this will make it so that when we press X, it opens. But we want it to close if it's released. So we'll say left claw dot set position. And let's say that 0 was closed. We'll do the same thing for right claw. So now we have it so that when X is pressed, it will set the position to 1, which is in our case open, and if it's not pressed, then we'll set the position to 0, which in our case is closed. So now we have our working specialized servo claw teleop class. So that's all for this video. Be sure to check out the next one for more FTC programming basics, where we get into how to implement and write your own methods into your code, and a little bit of autonomous basics. And then also be sure to check out the Java syntax video that we've made, which will help you understand some of the various symbols Java has, and also some naming conventions.